Well, here we go. We're gonna get everyone logged in, and we will get started. Well, it's about that time. So we're going to get rolling here. All right. So before we get started, how are you guys doing with your reading with Midsummer Night's Dream? No one knows what I'm talking about. Don't you guys have to read a mini version of the story for Miss Elliot? Yeah. Yeah, so I found out about that and I decided I'd read it as well. Now I don't have the short version story, so what I did was this. I posted this on my YouTube channel, so I don't know if she would consider it cheating or not, but I found a version of the text that is like the original, written in whatever century English Shakespeare wrote it in, and then it had a modern day translation, so I could actually understand a lot of the um, metaphors that he uses. Excuse me. I always yawn on my second stream of the day. Anyway, so I've read. I'm most of the way through Act One, Scene One, and it's kind of a messed up story at first. I'm not sure how far you guys have gotten, but so far I understand the main players, I guess, in as much as, let me scroll ahead. So I got these little pictures of the characters, so I can sort of have a visual who they are. So yeah, so this whole love triangle between Eugenius' daughter Hermia, and so Hermia loves Lysander. Lysander's clever. He says something I thought was really funny. Uh, but he's but Hermia is promised to Hermia is promised to Demetrius, and I thought it was funny that Eugenius is basically saying, "Okay, daughter of mine, either you're going to marry Demetrius, or you're going to get put to death because that's the law. You do what I say, or you die." And then Hermia, asks the Duke Theseus, like, "Okay, so do I really have to die? Is there another option?" And he's like, "Well, I mean, I guess you could go live as a nun and never have a family." And she's got 4 days to decide whether she's going to marry Demetrius, which is what her father wants, or go live in a nun because that's her third option, or just die because they're going to put her to death. And I don't know. It is a messed up little moment here for little Miss Hermia, but Will Sanders said something funny like, "Hey, her dad loves Demetrius so much. Why didn't he marry him?" And uh, I gotta wonder how boring or tedious or rude does Demetrius have to be for this woman to be like, "Yeah, I'd rather just live as a nun. You know what? Not for me." So I don't know, but if you want to go check out the recording, it's on my YouTube channel. And I guess it took me half an hour to get to a certain point. I was just reading casually, so I think with one more session I'll finish Act One, Scene One. But yeah, so seems like a good story. But we'll go ahead and get into math stuff now. Get rid of you. Get rid of you. Okay. Let's start with this, friends of mine. All right. Paper pencil would probably be the fastest way for you guys to do this. But here we go. So the lesson is equations with variables on both sides. So essentially, what you're being asked to do is be an absolute master of inverse operations, integer use, things like that. So for this guy, I'm just gonna go ahead and type this out again so I can start manipulating. So we've got -7 plus 4m plus 10 equals 15 minus 2m. Okay. And we need to solve for m. So drawing on what we were doing, some of the stuff from last week, combining like terms, I'm going to notice pretty quick here, like on our left side of the equation, this -7 and this 10, those can go ahead and be combined now before we bother doing any inverse operations. So -7 plus 10 would be 3. So I'll have 4m plus 3 equals 15 minus 2m. I really haven't done anything with the rest of this equation. Okay, so now at this point, there is no combining like terms to be done. This has an m, this does not, this does not, this has an m. So what we're going to do now, and no one can tell you to do this, you just have to notice the moment. I'm going to go ahead and get all the m's on one side. So the opposite of a -2m is a positive 2m. And whatever I do to one side of the equation, I have to do the other side. Now, the whole reason I'm doing this, and I'm abusing this rule of whatever I do to one side, I do to the other side, but the reason I'm doing it in this fashion is that a -2m combined to a 2m makes nothing. That is a rule we're going to be abusing here, that any value plus its inverse equals 0. That's the abstract rule we're just going to be abusing at this moment. So then we can also, I want to get all the m's on the left side and the constants. That's the whole numbers on the right side. So the opposite of adding 3 is subtracting 3, or combining it with a negative if it's inverse. So same thing. So I'll just go ahead and subtract 3 from both sides. And the reason I did that is that positive 3 negative 3 makes a 0. So what we end up with, 4m plus 2m is 6m, equals 15 minus 3 is 12. So the last inverse thing we have to do, if we would have m equals blah, because that's what our question is asking for, we would divide both sides by 6. So the other inverse operation is division in this case. And the reason we did that is that we're abusing another rule, and that is that anything divided by itself is equal to 1. So this right here is equal to 1. And the reason I'm crossing it out is different from the reason I crossed out up top. So when I crossed these out, these made zeros, and adding 0 doesn't change anything. Well, in this case, we're multiplying. We're not adding. Multiplying by 1 doesn't change anything. So 1 times m is just m. 1. And 12 divided by 6 would be, oh, whoa, hang on. Let me rethink that. Would be equal to 2. So after all that, we should have an m value of 2, which it is. All right, you guys try this one. So take this and go ahead and see if you can do some inverse operations and figure out what a would be equal to. I'll give you a minute head start. Okay, so a minus 15 equals 4a minus 3. All right, well, I guess the first thing I would do is, I guess I would subtract a from this side, and then subtract a from this side, and in this case, I would add 3 to this side, and I would add 3 to this side. So a minus a is 0, negative 3 plus 3 is 0, so what you end up with, negative 3, I'm sorry, negative 15 plus 3 would be negative 12. 4a minus a would be 3a. So then we can divide both sides by 3. And you would end up with negative 12 divided by 3 would be negative 4. And you would just end up with a, because 3 divided by 3 is 1, and 1a is the same as a. So the answer should be negative 4. Let's test it. Sweet. Okay. Let's move on to something a little bit different. I'm going to pause there, actually. Any questions about this one in particular or anything that's going on? Because if you are good, we'll move on to something else. You guys took time to be here. Otherwise, I will just move right along. Okay, next up. It's going to look really similar. Okay, so this is the exact same skill, but it's going to have fractions and decimals in it. The steps do not change. Writing it down gets a little bit more tricky, though. For instance, for this one, 9 fourths y minus 12 equals 1 fourths y minus 4. Okay. So 9 fourths y. Minus 12 equals 1 fourths y minus 4. Okay, and it might look drastically different, but the mechanics are the exact same. So I'm going to go ahead and take away 1 fourths y from this side. And I'll take away 1 fourths y from this side. And the reason I'm going to do that is because this will make it 0, because 1 fourths y minus 1 fourths y is nothing. And then what I can also do is that I can add 12 to this side and add 12 to this side. And the reason I would do that is because negative 12 plus 12, that makes it 0. So by those two maneuvers, well, I'll end up with now 9 fourths minus 1 fourth be 8 fourths y equals Let's see. -4 plus 12 would be equal to 8. So, oh yeah, and 8. What's 8 divided by 4? 2. So 2y equals 8. And the number you multiply by 2 to get 8 is 4. 4 times 2 is 8. So that should be right. It is. So the mechanics do not change just because they give us fractions or decimals. Like here's the decimal version. So 2d plus 4 equals 10 plus 2.5d. And nothing has changed about the actual steps in mechanics. So we can just, I usually do the subtracting whatever's smaller, so I'll have positive values left over. So I can take away 2d from this side and take away 2d from this side. That means I can take away 10 from this side, take away 10 from this side. So what just happened? 2d minus 2d is 0. 10 minus 10 is 0. If you did this in the correct spots, what you end up with, 4 minus 10 is a -6. 2.5 minus 2 is just 0.5d. So the inverse operation you would do now is you just need to divide both sides by 0.5. Okay. And the reason I'm doing that is that 0.5 divided by 0.5 is 1. So you just end up with 1d. -6 divided by 1/2. All right, well, there are 2 halves in every whole number. I mean, that'd be the same. If you were to double these, that'd be the same as -12 divided by 1. Just equivalent fractions. Just multiply both times 2. So it'd be -12 divided by 1, so it'd be -12. All right. So Cole and Brooklyn, you're here. So do you want to see another one of these, or you just feel like moving on to something else? Waiting on chat. No response. Okay. Okay, we'll do one more. Here's an interesting question. I wonder if kids doing lessons at home across the nation, I guess, I wonder if they're doing the same things they do in class, like like leave wrappers on the floor or break their pencils apart and just leave it on top of their kitchen table or wherever they're doing their math. I wonder if they do those little things they do in my classroom at home. It'd be interesting. All right, so now we've gone back to the fraction version, but nothing about the mechanics of the step-by-step has changed at all. So in this case, this being, okay, so let me write down, so -1/4. -1/4 a minus 4 is equal to 7/4 a minus 3. Yeah, so I'm going to get all the a's on one side by just adding 1/4 a to both sides. And then in this case, I'll add 3 to both sides. And the reason I did those things, and the more you practice, the more you just kind of see the road, you see the next steps as you're going. So -3 plus 3, that makes 0. So that's nothing. And then -1 force A plus 1 force A, that makes nothing. So where we end up, -4 plus 3, that's -1, equals 7 force plus 1 force would be 8 force. I can do better than that. There we go, 8 force A. So -4 plus 3 is -1. 7 force plus 1 force would be 8 force. That's equal to 2. So that's -1 equals 2A. And last step, all you have to do is divide both sides by 2. 2 divided by 2 is 1. So 1A, which is just A. So it's -1/2. So let's see. So -1/2 should be the value for A. Sweet. So let's look at something that might be a little bit different. Okay, equation with parentheses. What this is really getting into is that you're going to be using the distributive property. Not so bad. So if you write this one down in your paper real quick, what I want you to try to do is take this 2 and you need to multiply it by both of these terms. That's the distributive property. So go ahead and try that real quick. Okay, so hopefully here's where we ended up. All right, so you would still have this 10b minus 3 equals, now 2 times 12 is 24. And 2 times 4p would be 8p. Minus 7. And at this point, we start going into the previous lessons we've already practiced where all these skills start melding into the same lesson. So combining like terms, I've got a 24 and a -7 that don't have any variables, so they can go together. So I'll end up with 10p minus 3 equals 24 minus 7 would be 17? 17 plus 8p. Yeah, now I feel like I'm right back in the last lesson. So what we can do is that we can take away 8p from both sides. And then we can add 3 to both sides. So that means that positive 3 and negative 3 make a 0. 8p and negative 8p make a 0. And where we end up, 10p minus 8p is 2p. 17 plus 3 is 20. So you just simply divide by 2 to get 1p all by itself. And 20 divided by 2 is 10. So I'm hoping p is equal to 10. And it is. Ah, the negative nothing. Okay. So I guess I should do a little bit of translating here. So this equation right here, there's actually sort of a hidden number because the math people are so lazy. Sometimes you don't even bother writing it. So in this case, what you're really looking at is negative 1 times 4 plus h equals 3h. That's what you're really looking at. That negative symbol on the outside, it's really like a negative 1. So what you've got to do is distribute that to both terms on the inside. So negative 1 times 4 would be negative 4. Negative 1 times h would be minus h. The 3h is not affected. So now, I guess what I would do is I would add an h on both sides. The reason for that is that negative h plus h makes nothing. So we'd end up with negative 4 equals 4h. It's 3h plus 1h is 4h. And the last thing we can do, we can just divide both sides by 4. So h would have to be equal to negative 1. 4 divided by 4 is 1. So you got h. H equals negative 4 divided by positive 4 would be negative 1. And I did not draw that very neatly. Try that again. So that means that negative 1 is equal to h. Which it is. Yeah. So there's that. So when you got parentheses, that usually just means you'll have to do a little bit of distribution. Not the end of the world. Our time is going to be out before I know it, so I'm going to make sure to move on to something else. So anyone watching on the replay gets plenty to look at. Similar pattern here. So now this is the exact same skill we were just using, except this time they're going to give you decimals and fractions. You cannot avoid those things. You got to just dig deep, go back to your 6th grade and 7th grade skills and bring them forth. So what we're looking at here is doing this 4 and distributing it to both of these terms. So 4 times a half, 4 times 0.5. Well, that'd be 2 because every 2 halves makes a whole number. So that would get you 2f Positive times negative, so I know it'll be negative. 4 times a negative 25 hundredths. That's a quarter. So 4 of those makes $1. It's 1. So 2f minus 1 equals 6 plus f. Well, okay. Fair enough problem. Fair enough. I guess I could just take away f from both sides. And then I could add 1 to both sides. Two f minus 1f would just be f. negative 1 plus 1 is 0. 6 plus 1 is 7, and f plus negative f is 0, so I'm pretty sure f is just equal to 7. Okay. So it's the same skill, and if they give you decimals, if they give you fractions, it doesn't really change the order of operations. You just attend to precision. Be careful with your work. So now we're going to move on to something a little more. I think it's more interesting than just solve for problems. Okay. Number of solutions to an equation. Okay. So let me just start this section with a little preview as to what they're really asking you for. No solutions. Okay. When you get no solutions, that means at the end of all of your work, you'll have something like this. 7 equals 12. That makes no sense. So we call that false. So after all of your arithmetic, all of your combining like terms, all of your inverse operations, everything, if you end up with something like that, 7 equals 12, that means you have no solutions. Now, if you were to do all of your work and you ended up with 7 equals m, you'd have one solution. So when you come out to, and this is just the standard problems, you letter equals number. I mean, yeah, you got one solution. So the other tricky one is this one down here that says infinitely many solutions. Yeah, I thought I was gonna say infinite, and then I messed up the word. Infinitely many solutions. So here's how you recognize this one. If you end up with 7 equals 7, and this can be replaced by any number, or it's just a true statement, that's when you know you found an equation that has an infinitely number of solutions, infinitely many solutions, I should say. So that being on the table and that being understood, we can proceed. No solutions is when we get a false statement at the end. Infinite solutions is when we have a true statement like 7 equals 7. And one solution is where we just have letter equals number. Okay, so that being said, let's go ahead and try and tackle this problem. Okay, so let's go ahead and combine some like terms here. 23y and 27y can both be combined. So that would be 50y. So what we get after we add those two things is that 50y, actually I can type this, hang on. So when we add those two things together, we end up with 50y plus 50 equals 50y plus 50. 50y plus 50 equals 50y plus 50. Huh. Which does that look like? I just did something like this. 50y plus 50 equals 50y plus 50. They're the exact same thing on either side. And I did tell you that if you end up with the same thing, like a 7 equals 7, like obviously this isn't as basic as that, but this should be infinite. Because we had the exact same thing on both sides of the equation. Let's try this one. Okay, so this is going to combine some previous skills we've done today. So we've got to do this distributive property right here. So that means you'd end up with negative 6x minus 42 equals negative 4x minus 2. Part of me is wondering if I could pick an answer right now. I'm betting it's going to be one solution. I'm betting it is, but part of me just can't, I just can't let myself just guess. So if I added 4x to both sides, and then I added 42 to both sides, and end up with 10x equals 40. And I know after division, I'm only going to have one answer. X would end up being equal to 4. But all I need to know is they come out with one answer. I wonder if I can get one with no answer. Let's see. So let's go ahead and do this distributive property here. So negative, you'd end up with negative 9x minus 54. Aha, I think it happened. So negative 9x plus 108. Yep, I'm pretty sure this is going to be a no solutions, but we can prove it. Because what if we just added 9x to both sides? And that's all we have to do to prove this. If you add 9x to both sides, that makes a 0. That makes a 0. So you end up with negative 54 equals 108. And that is not even close to being true. So that's how that works. Okay, we've been going for about 45 minutes. I'll leave it up to you guys that are actually here. Do you want to see one like something we've done already? Pardon me. Do you have a question about the one I just did? Do we want to move on to something else? What was my next? Parentheses, number of solutions. I guess I have one more thing we could do, and then we could call it a day, unless you guys have something you want to see repeated. This will be our sort of our last hurrah for the day. But basically, once I do this next thing, it will have covered the skills you need for this week's 2 assignments. Ooh, I didn't actually post them as assignments. I need to fix that. But anyway, okay. Let's take a look at this. And this is how we're going to end our day. Okay. What in the world can we do with you? Oh, So there's going to be a certain group of students that really don't like these because they need an answer. I want to know that x equals number, and you are not going to get that with these. So this is sort of like you go into the math gym and you work out your brain and you do everything you can, but ultimately, well, you'll see. So let's just go ahead and do our distributed property right here. So a times t will just be at. A times z is going to be az equals 45z plus 67. I'm having trepidations here, but I think I'm gonna go down this path and do it this way. So AT plus AZ equals 45Z plus. Now it wants me to solve for Z. That is the goal. So I'm gonna get all the Z's together. So let me go ahead and so weird. Let me go ahead and take away AZ from both sides and take away 67 from both sides. The problem here is like this cancels out, but that is, oh yeah, and this cancels out. Okay. But these two things can't really combine. So we end up with this really strange, okay. Let's see if this makes sense to everybody. So now I'm going to have AT minus 67 equals 45Z minus AZ. Okay. So now I'm going to factor. These both have Z's in them. So this could be written as, and this is a really high level skill. This is real brain power. Okay. So this would be the same as Z times 45 minus A. I still have this AT minus 67. So I just factored out a Z. Basically, these both had Z's in them, and I pulled them out and I made it into the problem that we saw the few of these before. We did the distributive property. Well, the factoring is the opposite of the distributive property. So I pulled out a common factor. Okay. And now, and this is where people really don't like it, I'm going to divide this whole side by 45 minus A. I'm going to divide this whole side by 45 minus A. And that way, that makes 1. And I end up with Z equals, and it's blah. And we'll see if I got it right or not. I hope I did. So what we end up with is Z equals AT minus 67 all over 45 minus A. And that looks a mess, but okay, so let's see if I can get this. So AT minus 67 on top and 45 minus A. They might even prefer to be negative A plus 45. Whoa now. Let's see what happens. Oh, yeah, nailed it. So that looks horrible. It looks gross. It looks way too complex, but it's just an abstraction. They want to see if you really understand the rules, and to test you with that, they're just not going to let things come out to whole numbers, not even fractions. They're going to let these variables just stick around and never cancel out. But I like a challenge, so that's what that is. And that would actually get you all the way to both of your quiz assignments. And I posted it as a message on Classroom, but not in the actual assignment tab, and I'll fix that later, as well as getting everyone's grades updated. So for those of you that are in chat, anyone have a question, concern, anything they need to talk about before we call it a day? I'll do more of these exact same problems tomorrow and so on. So if you're wondering, is this the last time I'll see this? Do I need to ask a question now? No, you don't have to. You can go try the lessons, then we can come back and revisit these skills tomorrow, which will be the plan. Okay. Well, I hope everyone is making their beds and staying healthy and keeping everyone and their families safe. And I hope everyone's reading their Midsummer Night's Dream, because right now it feels like a pretty dramatic story that really deserves to be read. But I miss you guys. I hope everyone's getting their work done in their other classes. If you need anything, email me. Take care of yourselves, and I'll see you next time.